Okay, all right. So we are now in the part two of the lesson. For this lesson, we will go over the piecewise function. So what is piecewise function? Well, it means that we are going to have a few pieces for the function. So we will, well, let's look at the notation right here. Okay. So in the past, we just have a single equation, right? So we would say f of x is equal to x squared plus 1, like simple. But now we're saying, oh yeah, actually we are breaking into the function into several pieces. Now, usually we have 2 or maybe 3 pieces. Now, of course, theoretically, we can go even higher in terms of the number of pieces, but we don't usually do that. So I would say most likely you're going to see 2 or 3 pieces. That should be enough to really test your understanding. Now, some students, they say that it's pretty challenging. I would say, actually, this could be one of the easiest thing ever. As the only thing that you need to worry about is that you can tell the x value and you know what equation you use. So I'm going to use some color coding to help you visualize this better, okay, just to get you started. So the first one, look at the g of x right here, example 4. We say, oh yeah, there are 3 pieces right here. And what are these 3 pieces? Now you can see that there are some conditions listed at the end of each piece. So we say this, we say, all right, if x is less than -1, we will go ahead to use this function, -2x plus 5. So if x is less than -1, we will go ahead and do use this equation, okay, -2x plus 5. So only if the condition is met, okay. Now, well, what about the next one? Oh, next one is that, oh yeah, so if x is in between -1 and 2, but it has to be less than 2, but it's got to be greater than or equal to -1, then we say, oh yeah, let's go ahead and use this equation, okay. It will be x squared minus 3. So if you have anything that's right in between, if the x value, it's right in between -1 and 2, we will do that. We will do just that. And then we say, okay, what about x is greater than 2 or equal to 2? Then we say, oh yeah, you're going to use the step function. So this part, it's going to be very simple. Now, the bottom part, the graphing part, that could be a little bit challenging, but we'll get to that later. But for this part, I can promise you, it's going to be extremely easy. The most challenging part would be how good your notation is. Are you good with your notation? Are you diligent in keeping your excellent habit of writing proper notations? That's going to be very crucial to your success on this topic. Okay, so let's start with the first one. We say, okay, what is g of -3? Well, what does it mean? Well, again, this is our new x value. Okay, this is our new x value. We say, oh yeah, the x value is going to be a -3. So now I'll give you 3 seconds to think. Which function are we going to use? All right, so let's go. 3 seconds. All right, did you pick the good one? Okay, so is it the top one, the middle one, or the bottom one? Okay, so if you pick the top one, congratulations. We are going to use the top one. And therefore, we will go ahead and write down -2. And we're going to have a new x value, which is -3. We're going to put that later on. So I'm just going to prepare the parentheses, and I'm going to put that -3 right in there. And what's left? Just be careful. Okay, -2 times -3 is +6. And then plus 5, it's equal to 11. That's it. Okay, it's very straightforward. If you have good notations, you'll be fine. Okay, if you understand what you're reading, if you can interpret what you're reading, you'll be fine. All right, let's move on to the bottom one. What about g of -3/2? Okay, now if you are good with mental math. 3/2 is equal to 1.5, right? So negative 1.5. That is less than negative 1. Negative 1.5 is less than negative 1. Therefore, we're going to use the top equation again. Okay, so we say, oh, yeah. So that negative 3/2. Now, it's very important that you can see what can be simplified right here. The 2 in the numerator and the 2 in the denominator, they can simplify each other. So for the first part, we just have negative 1 times negative 3, which is positive 3 plus 5. It's equal to 8. Straightforward. Very straightforward. All right, now, if you want to, you can pause right here and go ahead and try the remaining. Okay, you can go ahead, make sure you pick the right one. Okay, now if you are not very confident, keep rolling. Okay, just keep watching. So next up we say, oh, what's g of negative 1? Negative 1. Which one is including negative 1? If x is equal to negative 1, which function do we use? I'll give you 3 seconds to pick. Okay, which one are we going to use? Well, we're going to use the middle one, because we say x is greater than or equal to negative 1. So we say, all right, x squared, we're going to put in the new x value, which we will put the negative 1 right there. And what is negative 1 squared? Well, negative 1 times a negative 1, it's positive 1. So 1 minus 3, it's equal to negative 2. Right? Again, very straightforward. Just follow the notation. Make sure you know what you're reading. Okay, good habit. Use parentheses for your substitution. Don't make things more complicated than it is. You'll be good. All right, what about g of 0? What about g of 0? We say, oh, g of 0, give you 3 seconds to think about it. Okay, so 3 seconds passed. It will be, again, the middle one, because 0 is right in between negative 1 and 2. So therefore, x squared, but we were going to put in the new x value. So the new x value is 0. 0 squared is 0 minus 3, negative 3. Okay. What about g of 2? G of 2, should we use the second one or the third one? Okay, give you 3 seconds. And the answer is, well, x is equal to 2. So in that case, we cannot use the second one, the middle one. We have to use the bottom one, the step function. So we say, oh, yeah, step function of 2. That is 2. Okay, so from the previous video, you learned about that the step function of an integer is the integer itself. What about the next one? G of 2.7. It's greater than 2, so it's got to be the step function. So step function of 2.7, okay, it's equal to 2. Okay, I hope you agree with me that it's pretty easy. So just be cognizant of what you're reading. Just be aware of the notation. If you are good with notation, it's super duper easy. So what about g of 3 2/3? We say, well, it's bigger than 2. So we're going to use the step function of 3 2/3, which goes back to the previous integer. It's 3. Okay. And what about pi? G of pi. Pi is 3.14, so it's greater than 2. So, well, I mean, roughly 3.14. It's not exactly 3.14. So the step function of pi, it's equal to also 3. So you can see that this is really straightforward. I want to help you to see it, visualize it. So I color coded these things in colors. So again, please practice good notation writing. That's going to help you in this course in pre-calc, and that would pay tremendous dividends. Okay, and I'm not kidding, I'm not exaggerating. I went through the process. I promise you, you will love calculus if and only if you have good notation skills. If you don't, if you write math like a mess, if you don't have good handwriting, if you have poor handwriting than me, well, I'm just going to say, be aware. All right, you are warned. Okay, so I'm not trying to scare you. I'm just going to be honest with you. Okay. Now, so what about the graphing part? Now, again, we have these pieces. We have the x less than or equal to 1. That would be 2x plus 3. And then we have the x is greater than 1. And then we have this negative x plus 4. So we're going to draw these two graphs. Okay, now I want you to imagine this. Okay, I want you to imagine that it's like you look at the graphing area on the right. It is almost like you are going to separate the graph into two different regions. Okay, you are going to separate this into one region right here. Okay, the region on the left, it's going to follow 2x plus 3. Okay, and then the region to the right hand side of it, this region, okay, that's greater than 1, we will graph negative x plus 4. Okay, so I'm going to go through how to properly draw these graphs. Now, these two will be somewhat simple because they are linear graphs. So my expectation is that you can tell that the slope intercept form. You can interpret the slope. If I give you the x value, you'll be able to give me the y value or function value swiftly, okay, with no problem. If you're challenged in finding the y value or not knowing how to do this, then I would say you need some review on how to get these graphs drawn. Okay, so now, so let's start with the first one. Okay, let's start with the first one. Now it sets x is less than or equal to 1. So let's go ahead and investigate. Where would it be when x is equal to 1? So we say, if, that's too thick, let's make it thinner. So we say if x is equal to 1, then we will use the top equation and say 2 times 1 plus 3 is equal to 5. So, well, actually, I should also say this, f of 1 is equal to 2 times 1 plus 3 equals to 5. Okay, so we will have a closed circle at 1, 5 right here. Okay, all right. So if we draw the graph from left to right, this is where the orange graph would end. Okay, now you have the slope, right? You have the y-intercept, which is 3. So we may go ahead and plot that point as well, and you can clearly see how it is a slope of 2. Okay, you can see that it is a run of 1 and a rise of 2. So rise over 1, it's 2. So we can just go ahead and make this very nice linear graph. All right, it's going to show up as a linear line. So let's try again. All righty, so let's just try your very best to align. And I would suggest you to use a straight edge to draw it if you have it. Yeah, and it makes it nicer. Okay, if you could make it nicer. All right, now, do you have to plot this point? Some people may ask. I mean, it doesn't hurt you. Okay, it gives you some guidance. It confirms it. Okay, teachers are not going to take up points if you plot an extra dot. You're just trying to confirm the accuracy, right? So we'll do that. So the orange part, done. So let's look at the next part, the green part. Okay, when x is greater than 1. Now, so here's the thing about x is greater than 1. So x is not equal to 1, but the graph is gonna start when it is 1.000000001. So it's pretty darn close to 1, but it's just not 1. So what we would do is that we're going to place an open circle, okay, not a closed circle, but open circle, when x is 1 for the bottom equation, negative x plus 4. Because while x is not equal to 1, but it's, again, the graph would start right next to 1, to the right-hand side of 1, not 2, but right-hand side of 1, like 1.000000001, or even more zeros. So we say, all right, so if x is equal to 1, then we say negative 1 plus 4, which is equal to 3. So we are going to plot a point at 1, 3, but this is going to be an open circle. It's not included, it's excluded. Okay, it's excluded right here because the graph is going to start right next to it. So we say, all right, let's go ahead and find that out. And then we say, what's the slope? The slope is negative 1. So, so I don't really need to come up with additional values because I know the slope of negative 1, which is going to point down, and it's going to go down 1 diagonally. Okay, so we say, oh, this is the graph. Now, if you're unsure, you may go ahead, propose an x value that's greater than 1, find out the y value, and then plot the point to help yourself out. But you must double check just in case, sometimes careless mistakes may occur. So just make sure that the slope is indeed negative 1. So for this graphing exercise, it's done. Done. Okay. All right. So again, we have a closed circle for the orange part because x is indeed equal to 1. So we use the top equation. But why do we care about the open circle? Because the graph is going to start immediately after it leaves the x equals to 1 value. So we're just going to place an open circle to tell the world that, hey, I know that. I know that x is not equal to 1 for the green graph, but it's going to start right after 1. Okay, so we just place an open circle to indicate that. All right, so we have that. Now, question number 6 could be a little bit challenging because something that you should have learned in Algebra 2, for example, you should know that for x squared, the quadratic function. Now, let me go ahead and make some rough sketches right here for a few important functions. Right here. Okay, so we say, all right, do you know how to plot y equals to x squared? And we say, oh yeah, it's a parabola. Okay, it's a parabola. You should know that. If not, then what I would suggest you to do is that you may go ahead and use decimals or your graphing calculator just to, y equals to x squared. Observe it, propose some x values, make a table, get the y value, then you can see it for yourself. Okay, it is extremely crucial that you have some of those, well, like not some, like all of those simple functions like quadratic function, linear function, rational function, exponential function, logarithmic function. Okay. And today we learn about step function. Okay. Later on, we'll talk about cubic function, square root function, polynomials. Okay. So we're going to learn a lot of graphs in this course. And now, speaking of graphs, I have a little confession to make. I used to not like graphing at all. Okay. I think some of you may resonate right now. And I can confess to you that I realized that I was a fool when I went to a calculus, because I realized that if you know how to graph, life is so much better if you know how to graph. And here's a little nugget for you too, which is that if you are going to take the SAT, I would tell you, if you know how to graph, if you can visualize the graphs, your life, it's so much easier. Your score will be so much higher. Getting 700 Not a problem. We will be talking about 750 or above if you know how to graph. So if you care about your SAT score, if you care about your welfare in calculus, I would say learn to graph. It's not that hard, but it gets some it takes some practice to get used to. That's for sure. All right. So you need to know that x squared is a parabola. And of course, you need to know those transformation. Like if there's a minus, what would you do? You have a reflection over the x-axis. So it's going to be become a downward opening. Okay. It's going to be an upside down U shape graph. And we have a +1, okay, a +1 in front of it. That means it shifts up, okay, vertically upward. So if you need some brush up with the transformation, I would say I hope I will make some videos later on. You can search on my channel. If not, just go to Khan Academy or just search on YouTube and try to make sense. But the bottom line is this: the safety net. Okay, you need to know where's the safety net. The safety net is make a table, propose some x values, find the y value. Okay, that's a safety net. Okay. Now, what about the square root function? Now, you should know the square root function. Now, I also tell students that a better way to understand this, these graphing is that try to make friends with them, friends. And by friends, I mean that you should know your friends' likes and dislikes. Okay. So we'll talk more about that, about parent functions later on. Okay. So for now, I'm just going to say that, all right, this is the y equals to square root x. If you know it, great. If you don't, get a table, make a table, propose some x values. So you can make the same graph. And then, of course, you have the y equals to x. That's the linear function, y equals to x, right? Okay, so it goes all the way. So we're going to use that to use these functions as a foundation to learn how to graph this. So we say, oh yeah, so x is less than 0. Now my approach is going to be this. I am going to draw the original graph, and I'm going to erase the part that we don't need. How about that? Okay, how about that? So we say, what is 1 minus x squared? Well, first, if it is x squared, negative x squared, we will do this. All right, it's a parabola. Go this way. Well, that's kind of ugly. Let's do this. Okay, it's going to go this way, and then we're going to shift up by 1 unit. So it's going to be like this. And that's our graph for 1 minus x squared. However, it only applies to what? It only applies to the x less than 0. So we have to erase the positive part of the graph. And then in addition, since it does not equal to 0, we would draw an open circle. Okay. So if you know how to graph, that would be wonderful. If not, again, make a table. Okay, make a table. What about the next one? Okay, what about the next one? Let me go ahead and highlight the first graph in blue so that you can have some color coding to follow through. The next one, let's use green. So it sets from 0 to 4, and it is square root x. So square root x, as you can see right there, okay, this is square root x, and that's no transformation, which is wonderful. So we say it starts from 0, 0, and when x is 4, y is 2. Wait, hold on, does it equal to 4? No, it is excluding 4. That means we have an open circle when x is equal to 4. So we will have this little curve for the square root function. Okay, we have a little curve for the square root function. Let me go ahead and make this slightly thicker so you can see this better. All right, so that should help. Okay, so all right, so that's the middle part. Done. And what about the last part? The last part is when x is greater than 4 or equal to 4. We would draw this instead. We have 4 minus -1/2 x. That means we have a slope of -1/2. So it's going to point downward. Okay, we should know that before we start plotting. And let me see, where should I put the point? Well, if you're not sure, well, guess what? Well, go ahead and calculate it. So we say, if x is equal to 4, let's see, it's going to be 4 minus 1/2 of 4. The x value is 4. So we have 4 minus, well, 4 times 1/2 is 2. So 4 minus 2 is 2. So that means I'm going to put a point that is 4, 2. Oh, it's actually the same point, 4, 2. So to show it better, I'm going to illustrate that. I'm going to close the circle inside the green open circle. Okay, so hey, it's a continuous graph because it connects with the previous piece. And then we say, what's the slope? -1/2. So it's not very steep. So it should be something like this. Okay, right, pointing down. Okay, it goes down 1 unit and goes to the right 2 units. That's -1/2 slope. So so that's it. That's it. Okay, that's our graph. Done, finished. Okay, finish. Right, finish. So easy, easy, very easy. Let's move toward the final piece. The final piece is about the, we give you the graph, and now you have to give us the function. So we say, there's clearly 2 pieces, and that's why you need to know your functions. You need to know the general shapes. If not, then it's going to be very challenging for you. So we have what? We have, let's just say f of x, okay, is equal to, we're going to have 2 pieces. Let's go ahead, write down the conditions first, because it's pretty easy to see. We can see the first piece, the one on the left. Let me use green to highlight that. That is going to be x is less than or equal to 0, because we can see a closed circle right here. That means it is equal to 0, and to the left of it, so less than 0. And what about the other graph, the one on the right? We say, oh yeah, that is when x is greater than but not equal to 0. So x is greater than 0. So we have these 2 pieces. The left piece, wow, this question is so generous. It gives you the y-intercept. The y-intercept is 1, 2, 3, 4. So we have a 4 for the y-intercept. The slope is a 2. So we have 2x plus 4. Okay, 2x plus 4, that's the slope of 2. Rise of 2, run of 1. So rise over 1, 2 over 1, that's 2. 2x plus 4. That's our first piece. Okay, the one on the left. All right, the one on the left, that's this part. Okay, let me just color code it. All right, that's this graph, so you can see it better. And then what about the other piece? This one. Well, that's a quadratic. And this one is a quadratic with leading coefficients of 1, because well, it goes well, let me change the color back to orange. It goes right 1, down 1, and then right 1 and down 3. So that's resembles the a value of 1. So we say, oh, that's a parabola. It's opening down. So it's minus x squared. And then the whole graph is being moved up by 3 units, so plus 3. Now, you may also write 3 minus x squared. That's okay. They're equivalent, no problem. Okay, so either this one or this one, they are equivalent. Okay, so you can write either one of these 2. So the advice is this, before we say goodbye right here for this lesson. The advice is that you must know your basic graphs. You must know the graphs of your basic functions, that they were covered back in algebra 2. So if not, that's going to be some trouble here. So I probably will make one in the future, and I will let you know. Okay, so you can search around. You can search on my channel, and then you can see the introduction of those basic parent functions, the basic functions. All right. So let's stop right here. And yeah, let's keep it like this. Yeah, let's stop right here. And next time we will talk a little bit more about, we will head into the polynomial stuff. But But I hope you understand the piecewise function and also the step function throughout these two videos. Okay, I wish you good luck and make sure you have great notation skills. Okay, that's the best thing I can help you. If you don't have good notations, it's over. Okay, it's non-negotiable. All right, so good luck.